Okay, so far we have completed um, only one command in a 6A60 interface that we were discussing: authentication information request and authentication information answer, which brings in authentication parameters needed from HSS required for MME to calculate the ciphering integrity keys and also help the mobile equipment. We also help MME to validate the mobile. So for that purpose, we use this. So we have to see the remaining commands and in what situations the remaining commands would be used. So the one that we have studied was this authentication information request and authentication information answer that we have. All right. So um, what is the next command? Update location request and update location answer. So what is the purpose of this message, update location request and update location answer? Um, this procedure is going to be used by MME to update HSS that the mobile equipment successfully completed all its security procedures, and it is the time for the HSS to provide him with needed subscriber information. So uh, the request majorly won't contain any details other than the details are almost repeated: session ID, authentication session state, which will be set to no state maintained, and origin host, origin rem will be pointing out to MME's name and MME domain. So these things are for reference of HSS to help the DRS to forward. This username is your IMSI number, and as usual, you can report your supported features with respect to S6A. What are the different features you support? And terminal information is mobile equipment's IMEI details, and radio access technology type is mobile connected to which network. Like we will be specifying that it is connected to UTRA network, and there are some flags exclusively applicable only for your ULR operation. So flags are in the sense one bit values that one bit values together will they have formed one AVP, and depending on the flag, some features will be understood as enabled, disabled, or something like that. ULR related specific things. What is the mobile's present visiting PLM and ID, the network number, and if SGSN is requesting for this update location request, you will have SGSN number followed by some optional things like proxy info route record. We can always ignore. Okay. So once we give the user ID and in which radio technology network is connected and successfully almost about to be registered with PLMN ID, you have to send this update location request to HSS. HSS would be answering back with session ID result code, and these are HSS details anyway. The flags and features are almost same, but the most important information in this whole package is subscription data. These are the mobile subscriber details, like how many PDMs mobile equipment is can be connected to, how many under each PDN, what is the data rate restrictions, what is the maximum minimum data rate, what is the maximum data rate. So what are the billing rules or charging rules that are applicable. Like that, we'll be providing a lot of individual details over here. So that is update location request and update location answer. Of course, if it is failed, it will quote a reason why it is failed, because of which AVP this is failed, and you include this AVP if the result code is set to diameter failure. But if the result code is set to diameter success, this failed AVP information won't be present. All right. So the first command is authentication information request, gathering the authentication details to validate the user. So once the mobile user got validated successfully, MME is requesting HSS to provide subscription data, mobile subscriber information, to help the mobile equipment continue in this sell in a happier way. Okay, what next? We have notify request and notify answer. Again, who triggers it? It is triggered from MME. MME triggers it to um, MME triggers it to HSS. So what is this message? Notify request and notify answer. Notify request is to notify that a particular user has got a service established, like mobile equipment is connected to a new PDN or mobile equipment disconnected from a PDN. So that's kind of in such kind of events, MME must be reporting the situation to HSS. Hey man, you have told me that mobile is allowed to be connected to, 5 PDNs. Just now mobile equipment has got connected to its first PDN. Maybe after half an hour, we can go and explain HSS that mobile now got connected to another PDN. So every time the username, which is the INSI number, got connected to a service, we will be alerting what is the reason for it. Is it connecting to that service or disconnecting to that service? Like that, we will have explanation. Remaining all the informations are almost similar. But this context ID is referencing to a context ID number that is quoted as part of your previous message, that subscription data. Subscription data is divided into number of contexts it will be divided into. When when update location answer is coming back from HSS. So now in this in here, by quoting the context identifier, we are specifying HSS mobile equipment is connecting to this particular service, this particular service, which is part of which is subscriber information, which context ID that you have sent. So basically, we are giving a reference link to HSS. This service is related to the user subscription information you have provided, context ID number 5. So to that particular service, mobile equipment is connected now. It is that way. Service selection. A notify answer won't contain much of the details other than it is just a reply with almost all the details are replicated details. Of course, if failed thing is there, it will be present. If it is success, it will only contain these details, not much. Result code is success. And origin host, origin rem will be pointing out to HSS. This will be no state maintained always in all operations. And yeah, these two things are results only. The session ID, whatever we have quoted, the same session ID will be coming back as notify answer. So notify answer is not giving you much of the information. It is just explaining the MME that hey, thank you very much for letting me know that the mobile is connected to a new service and activated the new service. Thank you very much. Or thank you very much for letting me know that mobile equipment has disconnected from this service. Not only at the time of connecting, but also at the time of disconnecting also, MME will have to notify this to HSS. That's the primary idea. Next, IDR and IDA, insert subscriber data and insert subscriber data request. So what these two things are. If HSS finds out that the mobile is mobile has got some new data inserted, new subscriber information inserted by the operator into the database, HSS immediately himself on his own discretion, he decides to report this to the MME. Hey MME, listen, there is a new subscriber data got attached just now. Mobile guy have subscribed for new services. It is my duty to report you that new services. These new services belongs to this particular user, and this is the subscription information associated with it. I'm sending to you. So insert subscriber data request. Uh, so the so the logic for this is the HSS database somehow got modified. Who modified the HSS database? Operator might have modified the HSS database. Why operator has modified it? Maybe you have called the customer care center and you have asked the customer care center, I want so and so service. You have requested for that service, and your customer care center is accepting it and allowing it, allowing that for you. And they have made the modification in the HSS database, and HSS is immediately reporting it to the corresponding MME with whom the mobile equipment is registered. Of course, MME has got no important reply in the answer. It will be simply reporting the result code, and that's all majorly. So remaining information is almost getting repeated. A lot of AVPs in all the diameter messages are same. They won't even convey much of the meaning. It is the same information. All right. Now, delete subscriber data, which is the opposite of the previous feature. So what is delete subscriber data? If a subscriber has desubscribed from some services by talking to operator backend, so operators will delete the subscriber data from the HSS. So when the moment the deletion of the subscription takes place, immediately your HSS must be reporting it to MME that there is this deletion of subscription is going on. That is the meaning of delete subscriber data request. So you have the diameter header and followed by this thing. What services must be deleted? So you quote the username and you quote this context identifier. So what is this context identifier? I have already told you that the subscription data is going to be divided into context IDs, each context ID explaining one service. So now when HSS is sending you this, deletion, it will have to report you which one it wants to delete, which context or which service HSS is asking MME to stop providing it to the user. So that context ID is the important aspect. And there are other codes called as a TS code and SS code are also linked to your service only, and you will be reporting that if needed, but that's optional, but anyway you can report it. So you are deleting the subscriber data, and of course MME is going back answering to HSS, thank you very much, result code will be set to success. Rest of the parameters are almost same, no variance. All right. So what is the next message? Cancel location request and cancel location answer. Again, this is initiated by HSS. When this would be sent by HSS? Mobile equipment is registered with one MME, and suddenly mobile is moved out of that area. He has gone into a different area, and he communicated with a different MME and registered with that new MME. At the time when the mobile is registering with the new MME, that new MME will contact HSS, asking HSS that, hey, he's the subscriber, your subscriber. Can you please let me know his subscription data? I wanted to, he is asking me to allow the registration, I should decide. So then it is the HSS duty to provide the subscriber details to new MME. Of course, it provides the subscriber details after the mobile is successfully authenticated, etc. Once all that is done, what is going to happen is pretty much simple operation. It's um, the HSS, after it gets to know that mobile successfully attached with the new MME, it has to report to the old MME about this situation. So it will come back to the old MME and explain the old MME that, hey man, listen carefully, mobile is no more under your area. He is already moved into the new MME's location. He just now communicated with me and explained the situation to me, and I have decided to provide the subscriber information to new MME after the new MME successfully authenticated. Everything is done for the mobile. So you no need to keep subscription anymore, subscription information anymore with you. It's better it is better you simply ignore it. So cancel the location and forget about this particular subscriber information. You delete it so that you will not have huge amount of subscriber details in your database without those users being present in your location or in your network. We don't want that to happen. That is why we are asking for this. So it is what does MME do? MME will throw all the details of the user into dustbin and he accepts with the result code success. And of course, MME HSS will report cancellation type. Why it is being cancelled? What is the reason for this? So it can code that cancellation type. Typically, the cancellation type is like mobile is registered to a new MME. It's like that. Okay, so what is the PUBG request, PUBG answer? The next procedure. If MME finds out mobile equipment is not connected to him, mobile equipment registered with the MME, and at the time of registration, MME gathered subscriber information from HSS. It happened. And after the subscriber information has been received, MME is dealing with that mobile. After some time, mobile equipment has got deregistered. So still MME keeps the subscription information with him because mobile equipment again can come back into the same network and do a registration once again, do an attach. Mobile is maybe switching off his mobile, so it deregistered. We keep the mobile's information. MME keeps the mobile's information. But for how long mobile's information is going to be kept by MME? It is not for too long. MME waits for some amount of time. After that amount of time is passed by, MME comes to a conclusion, mobile is not going to come back for whatever reason. I don't care. So, but I have to go and talk to HSS and explain him that I'm deleting the subscriber information on my own because mobile is not coming to me for some time. So that is the meaning of this PUBG request. So only important AVP here is username AVP. So which user's information is being purged? Of course, HSS has got no business in this. HSS will simply reply back and say that thank you very much. That's all. So nothing much would be there in this. Okay. So PUBG request and PUBG answer. We have two messages over here. But HSS understands that mobile is no more with MME. Of course, it is VLR kind of function only. Because MME is basically MME plus VLR already. Because in old technology networks, we have in UMTS, SGSM plus VLR separate, MSC plus VLR separate. But in LTE, we have only a single MME which is acting as MME plus VLR also. It is a database, right? So MME is a database as well to store the information temporarily. So it is reporting to HSS that I'm no more storing the information of the subscriber anymore. I'm deleting it in my database because the user is disconnected from me from a long time and he is not connecting back. I'm reporting it to you. So that's the meaning of per GUI request. Maybe if no other MME comes to the HSS and says that this mobile is getting connected, anyway HSS will be running some timer. The moment HSS finds out that mobile is not registered for 3 months or 4 months, according to the government regulations, typically that number will be deactivated for suspecting things. So after that, if you try to use that SIM card and try to reactivate it or try to register with the network, network won't accept it if you have not used it for some longer periods of time. So for detecting that longer periods of absence, this PUBG mechanism will be helpful because MME immediately, after waiting for some time, if the mobile did not come back, you immediately have to report this to HSS, and HSS would keep that information in mind and also will be counting the days that the mobile is not connected to the network. So when that days crosses some predefined period of time, HSS will move the mobile into deactivated state or what do we call it? Maybe SIM card deactivated state. So after that, your SIM card will be no more useful. If you want to reactivate it, maybe you have to go to the back end of the operator and then request for it. Kind of that. Okay, one last procedure we have between MME and HSS is reset request. So if any kind of a reset happens, hardware failure or anything, so you will be sending this reset request. In this, we are going to have a AVP called as user ID AVP, which is not containing any minimum and maximum factors. So minimum is 0, maximum is infinity. Basically, these user IDs can contain n number of user IDs. The user IDs information that has been impacted because of this reset. So that is the reset request, and then accepting it is the reset answer. Simple. So this is again a failure scenario in case of a in case of a failure, in case of a problem that happens with the hardware. In such scenarios, we will be sending this reset. So this is not a UE specific procedure. This would be a generic procedure. Reason is at the time of resetting, there is a possibility that multiple users may be impacted. So multiple user IDs would be there. It is not one username. Earlier, for all our operations, a single username was involved. That username pointing out to the INSI number of the user. In all the previous procedures, username, we have username, username. It is all related to one single user, any information that we have studied so far. But this message is not related to a single user. This message is related to multiple users who have been impacted because of the reset. And the other guy is going to simply come back to you and report you that it is result code is success typically. And the only message that is present for us in interface S13 and S13 prime, that is MME to AR and SGSN to AR to validate the mobile equipment's IMEI number is ECR and ECA. We have equipment, ME check request, basically ME identity check request, ME identity check answer. To validate IMEI number. So what details would be sent majorly? Session ID will be there. This will be not maintained. Origin host, origin RAM will be either MME or SGSN, depending on who is requesting for it. Of course, all the previous procedures also, it can be MME or SGSN. and destination typically will be pointing out to AR network, AR name. Terminal information is your actual important details, that is IMEI number. So username is IMSI number, which is not mandatory. If MME want to send it, he will send this IMSI number. Or if MME is not having IMSI number, he will not include it. For example, if the mobile is doing a emergency attach without having a SIM card for making emergency calls like 100, etc. So that time, because you don't have the SIM card, you don't have the IMSI available. So MME might not code the IMSI number to EAR. It will only be quoting IMEI number in the form of terminal information. So once we send this IMEI number, what you will get back from EAR is equipment status. Other than the remaining general AVPs, the most important AVP that comes back in this ME identity check answer is equipment status, which will be pointing out to whitelist, grey list, or blacklist, reporting the situation of this IMEI number. If it is in whitelist or grey list, the calls would be the registration or any procedure that MME received will be accepted. But if it is in blacklist, the procedures will be rejected by considering it as a stolen mobile. So that's the idea. That is the equipment status provided to you by your EAR. So why the user name is being sent is IMSI number. So what happens when we send IMSI number to EAR is EAR will raise a red flag on this IMSI number. So, and these details would be forwarded to police department or whatever, especially when the terminal information status is turned out to be blacklisted mobile phone. The information goes to this IMSI number goes to police department automatically. So by taking this IMSI number and the IMSI number registered user information, they will be able to track the person who have stolen this particular mobile to retrieve it. It's like that. So for that reason. Or if there is a criminal who is whose IMEI number is known to the government is tracking him, but he's changing the SIM cards every now and then. So username reporting will be linking what and all the SIM cards this person is using. So with that particular mobile device. So irrespective of you keep changing your maybe not you the criminal changing the mobile device doesn't mean that he is escaping the tracing, because government has acquired your IMEI number. So obviously they will be able to use that irrespective of how many SIM cards you are the person is changing. So it's that way. Okay, so the total procedures we have between MME to HSS and SGS into HSS are 8 procedures. So the starting procedure is authentication information request. If MME successfully authenticate the user, MME goes and reports it to HSS and asks for the subscriber information by updating the location as his location. Right now the mobile is present under this MME, and if any subscriber information that is reported in update location report, if it is getting added, new subscriber details are getting added, insert subscriber data happens. If the subscriber data is getting deleted, delete subscriber data happens. If the mobile moves into a new MME, HSS reports to the old MME to cancel the location, cancel location request and cancel location answer. This cancel location can also happen in one more time if desubscription happens. For example, this month 31st you will lose your subscription. Now the 31st happened and the date passed, you did not recharge or you did not resubscribe. So HSS will send the cancel location request to MME, reporting him that the cause is not because mobile is connecting to another MME, because mobile subscription period is over. So you have to force a detach procedure. This time MME initiates the detach procedure. It is not the mobile initiating the detach procedure. MME initiates it because the user is not subscribed to our services anymore. Purge UV request, if the mobile is disconnected from the MME for too long, MME reports this to HSS and asks, telling that I'm deleting the user's subscription information stored on my side. If the mobile equipment comes back again into connected state, I will again request the user authentication details and subscriber data once again. But for now, time being, I'm removing the subscriber information on my side. So if reset occurs, reset request, reset answer will be taking place, and how many users data is impacted, we will be reporting. Notify request is to every time a mobile equipment is connected to a significant service or mobile disconnected from a significant service, it is MME that need to report to HSS about which services have been subscribed by the user or which services have been disconnected by the user. So HSS will be having complete information about user has used which and all services over a period of time, because it will be gathering all these important activated services. That information would be reported to HSS by MME. Okay, so this is on S6A and S6D interface. S6A is between MME to HSS, S6D is between SGS and to HSS. Now, S13, S13 prime. S13 is between MME to AR. S13 prime is between SGS and to AR. Only one message to validate your IMEI number. Sorry. With that, we are done with S6, S6A, S6D. What is the next interface we are starting with? Is GX. So we already knew the GX. Where is the GX interface? GX interface is between PCEF to PCRF, nothing but your P gateway to PCRF. So GX interface is required at the time when we are enabling any bearer PCEF, nothing but your P gateway must get the permission from the PCRF, and also he needs to gather quality of service information and the billing rules. We need to get all that information. So this GX interface is used for gathering such kind of information. This also works on Daimeter. A lot of interfaces work on Daimeter. So this interface also works on Daimeter GX interface as well. Okay, so before we study the messages and the procedures we have on GX interface, first we introduce a concept called as PCC rules. So the purpose of PCC rule is to detect a packet belonging to a service data flow. And then acting upon it. So the service data flow filters, nothing but your TFT parameters, traffic flow template parameters within the PCC rule are used for selection of downlink IP CAN bearers. Like these TFT parameters will help you which packet belongs to which service data flow. The service data flow is a technical word for your EPS bearer, simply. But in Daimeter, they won't use that terminology. Simply, they will use general terminology. Service data flow means that. So detecting a packet belongs to which service data flow, either EPS bearer, which EPS bearer. So same thing is going to be applicable for uplink IP flows as well. If we receive the data on a particular service data flow, you will identify that belongs to which uplink IP flow, and then transported it to the correct IP CAN bearer, IP connectivity access network bearer. Nothing but this is external bearer. We will be sending it out. So if the traffic is coming from external network to LTE network, your LTE network have to detect that packet must be sent on which service data flow. But if the data is coming in the uplink direction, service data flow is already identified, because mobile equipment identifies which data need to be sent on which EPS bearer, and mobile would be sending the corresponding information. So mobile would send this to HSS, and mobile would send the traffic on radio bearer to Node B to S gateway to P gateway. Once P gateway receives the traffic on that particular service data flow, it will apply some enforcement rules, and then it will send the data to the external PDN, an external bearer. So what is the purpose majorly? So identify the service data flow contributes to, and provide applicable charging parameters for that service data flow. Provide policy control, nothing but quality of service implementation for that service data flow. So the PCC rule is not only detecting that a packet belongs to which service data flow, but it also identifies what are the charging parameters that are applicable for that service data flow, and what is the quality of service we need to implement for that service data flow. So this is the actual concept of quality of service implementation in LTE networks. So you must be able to segregate. So that means, for example, if P gateway received 500 IP packets destined to the same mobile equipment, but these 500 IP packets we need to be segregating. 150 IP packets should be sent on default bearer. Another 100 packets should be sent on one dedicated bearer. Another 101 will be sending it on another dedicated bearer. Remaining 150 will be sending it on another dedicated bearer. So like that, we are dividing these 500 packets into, we are segregating it. The quality of service implementation for this first bearer would be different from all other bearers. Every bearer will have its own quality of service implementation. All bearers will have its own policy control, nothing but your data rate aspects, quality of service implementation aspects, like PCI, not PCI, what do we, QCI, quality of service class identifier. Okay, these PCC rules are the important information that exchanged between PCRF to PCEF, that is nothing but P gateway. But these PCC rules are categorized into two important categories, dynamic PCC rules and predefined PCC rules. What is the dynamic PCC rule? These are dynamically provisioned by PCRF to PCEF on GX interface at the time when the bearer is getting initialized, when a service data flow is getting initialized. So if a new bearer is getting initialized, then when we provide this PCC information dynamically at that moment in time, at the time the bearer is getting initialized or activated, then we would be having this dynamic PCC rules. Then what is predefined PCC rules? What is this predefined part? Predefined PCC rules are already available in PCEF. That means these are pre-configured in the PCEF, nothing but your P gateway. So the only job PCRF will do is dynamically it will be activating it and deactivating it. That's all. That means the rules information is already available in PCEF, nothing but P gateway is already containing the rule. So only duty PCRF is responsible for is at the time of at the needed juncture, we need to either activate it or deactivate it. So that is predefined PCC rules. So the operator may define a predefined PCC rule to be activated by PCEF. So such a predefined rule is not explicitly known in the PCRF. It is not known to PCRF. Only the rule is available in your PCEF. Operator configure these rules. So operator also can change the rules on his own or configure their own rules in on P gateway, and PCRF would be activating it. Okay. So, what a PCC rule consists of? What kind of information would be present inside this PCC rule? A PCC rule consists of a rule name, um, used as a reference for PCC rule in communication between PCEF to PCRF. Wherever PCEF is mentioned, guys, you can consider it as P gateway, but the convention used in the documents always is going to be PCEF instead of P gateway. Of course, PCP gateway is PCEF, policy and charging enforcement function. It will enforce the rules that are set by PCRF. Service identifier. This PCC rule is part of which service component, or which service component the service data flow relates to. This can even identify your user ID also, this service identifier. Service data flow filters. This is the traffic filters, nothing but your TFT filters. How to segregate the traffic that belongs to this particular service data flow, nothing but EPS bearer. How do we segregate it? That parameters are called as service data flow filters, TFT, traffic flow templates. We have named them earlier. Precedence, like what importance is this? Like what are the other ones, other PCC rules, etc. Gate status indicates whether the gate is open or closed for this particular service data flow. If any traffic arrives with this particular filtering parameters, whether the traffic must be allowed to send in uplink and downlink direction, or it should be not allowed. So if the gate is open, typically if the gate status is set to gate is open, then your P gateway will allow the data to be sent out and the data to be received in. It will accept that. But if the gate is closed, it would reject the transfer of the data flow. Quality of service parameters will be present inside a PCC rule, which contains QoS class identifier QCI, and allocation retention priority, the ARP value, and authorized bit rates for uplink and downlink for that particular EPS bearer, with which this for which this PCC rule would be applied. So the quality of service details and charging key and other charging parameters. There are multiple charging parameters would be there, like whether the charging is offline, online, etc., etc. So those things. Charging key is nothing but rating group. This data should be rated with which rule. So for different quality of services, different billing rules will be applicable. For example, if you are uploading the files, either using Facebook or either using WhatsApp, or if you are using any application and you are uploading the files, it will be considered as background data. Background data billing would be different. If you are using the same Facebook or WhatsApp and make voice calls, it will be considered as real-time data. And for that, quality of service would be different. For that, billing rule will be different. Rating group would be different. So that's the meaning of rating. Now it is not happening. Now, especially in India, it is not happening. Maybe in other countries it's already implemented. But in India, all our data is going to be considered equal, whether we make a voice call or whether we use it for browsing, file uploads, file downloads, movie watching, streaming, everything will be considered the same. But actually speaking, all the data, all different data flows are can be configured with different rating units, different charging mechanisms. So that is this charging key and other charging parameters. So this defines whether it is online, offline charging parameters. If it is a metered offline means limited offline, how much more data is going to be allowed, like that. That information will be provided. Okay, so for these PCC rules, what mechanisms are applicable? For uh, dynamic PCC rules, mechanism is a little different from static PCC rules or predefined PCC rules. For a dynamic PCC rules, which are going to be provided by PCRF on the go in the live situation, PCRF can install the PCC rule, modify it, and remove it. Um, so it is whenever he wants, he can install it. Whenever the bearer is getting enabled, you can install it. When the bearer is getting modified, you can modify the PCC rule as well. And you can remove the rule at the time when the bearer is getting deactivated, obviously. But in case of predefined PCC rules that are already available with PCEF stored in your P gateway, you only to perform these two functions, activation and deactivation. um, so activation is to allow a PCC rule being active, which is already available with your PCEF, nothing but P gateway. We don't need to send the rule. We just need to activate it. Or when the service is getting deactivated, you will deactivate this, do it, disallow the PCC rule, remove the rule. That's it. So installation, modification, removal, activation, and deactivation. Some more story we have. The PCRF shall provision the PCC rules to the PCEF via GX reference point. We know that the GX interface. Um, the PCRF PCC rule decisions may be based on one or more of the following. On what basis these rules will be decided upon? PCRF decides which PCC rule to apply and which PCC rule to send, etc., will be decided on the basis of information obtained by update from your application functions on RX reference point. So, if PCRF gathers on RX interface about what kind of a session is getting activated, what media and subscriber parameters are getting activated, depending on that, you can decide the PCC rule. That means we already knew this RX interface is existing between PCRF and application server. So if from application server, if PCRF gathers information related to the session we are going to activate, so then you will be sending, you would be deciding your PCC rule on the basis of that information procured. Or if the information is not provided to you by the application server, but if the information is provided to you by PCEF, nothing but P gateway over GX reference point at the time of establishing a bearer. So depending on the IP CAN bearer attributes and request type and subscriber related information, depending on it, you will be deciding the corresponding PCC rule. Or PCRF can make PCC rule decisions upon information obtained from SPR. SPR typically reference for SP reference point or subscriber and service related data. Nothing but any database that the operator maintains to store user related subscriber information. So this is not a technical interface that is going to be mentioned in our LTE specifications. This is internal database, so that is basically like that is available as a reference point for PCRF to gather the details about the users subscriber related information. For example, in some cases, this could be HSS. If there is a link existing between HSS and PCRF, a direct link, even though it is not through Daimeter protocol, but if the link is existing, your PCRF can gather some details from HSS directly, subscriber related informations, and based on that also it can decide the corresponding PCC rules that need to be applied. Or information obtained from BBRF. BBRF typically bearer binding function, we call it as. This bearer binding function typically represents S gateway. So at special scenarios, by using a interface called a GX6 interface, which is existing between S gateway to PCRF, a special interface, PCRF can gather some details, and by using that information also, we can PCRF can determine the PC's rule decisions. Or PCRF pre-configured information by the operator. So by using that, so by gathering the information from different components or on your own configured information, your PCRF can make the decisions about which PCC rule to be applied. Okay, that is PCRF functions. What is PCEF functions? PCEF is your P gateway. What the P gateway should do? P gateway will be, having the control on the user plane traffic handling to implement the quality of service and detecting that data belongs to which service data flow, counting the number of packets, and doing online offline charging interactions by communicating with online charging system and offline charging system, etc. For a service data flow that is under policy control, the PCEF shall allow the service data flow to pass through the gateway if the corresponding gate is open. Now, even if PCEF shall allow the service data flow to pass through the gateway only if the corresponding PCC rule is active. Otherwise, you should not. And moreover, one more condition is gate should be open. Both the things should be there. So if the PCC rule got active and as well as the gate is open, only in such situations you are allowed to let the data pass through. Otherwise, P gateway should stop the data transmission, both uplink and downlink. And also, it will be for online charging. If OCS has authorized a credit with the charging key, up to that credit is still there for the mobile, we can accept it. Even at the time of reauthorizing procedure, during the reauthorization procedure, if you want to accept it, you may accept the data. But after the reauthorization, you got to know that gate status has closed. For example, you should stop accepting the data. But during means at the time when the reauthorization is taking place, validating it one more time is taking place. So that time you may be allowed. Again, it will be decided by the operator. Operator will be choosing these options, what kind of implementation they wanted to do. So if requested by the PCRF, PCEF shall report to the PCRF about status of the related service data flow changes. That means if the service data flow is making changes to quality of service, or if a new service data flow is getting activated, getting modified, or getting deleted, etc., etc. So you have to keep monitoring that information, and PCEF must immediately, whenever he finds out by monitoring it, any IP bearer information changes, you must report it to the PCRF. So depending on that, PCRF might change the PCC rules when you report him. So in which and all situations you will be requesting for PCC rules? Typically in two scenarios. When IP CAN session establishment, IP CAN represents IP connectivity access network session, which is nothing but helping the mobile equipment to connect to a PDN, packet data network, and enabling an APS bearer related to it. That is what we call it as an IP CAN session. Now, at the time of session establishment, PCEF, nothing but P gateway, shall send CC request message with the CC request type AVP set to initial request. It will be setting it to reporting that it is the new thing. It is not, I'm not talking about an existing thing. I'm talking about a new thing, a new user, new bearer, new IP CAN session getting established. It is about that. So PCEF shall also supply a user ID within the subscriber subscription ID, AVP, etc. Other details also will be sent. I have ignored a lot of other details, but the primary informations are these: what is the user ID and whether it is initial request or something else. So if it is the initial request at the time of session being established freshly, but if a session being modified, for example, that time PCEF will send the this at the time of modification, PCEF shall send the CC request. With CC request type, AVP must be setting to update request. Value would be set to update request instead of initial request. So when this modification, what is the meaning of modification? A bearer is being, when a new IP CAN bearer is being established, modified, or terminated, when bearer is coming up. Now this IP CAN session establishment will come into play when you are connecting to the PDN and we are enabling a session basically. And when the session modification means anytime when a new additional bearer is coming up and the bearer is getting modified or bearer is getting terminated, or if UE has requested to modify the existing EPS bearer from quality of service point of view, or any other event trigger happens, like deletion gets triggered by, for example, if P gateway detected there is no uplink data going on, there is no downlink data going on, or data got stopped, or any such event occurs, any such event takes place, then also we do the IP CAN session modification. So so the two important aspects: IP CAN session establishment, IP CAN session modification. In modification itself, we have bearer establishment, bearer modification, bearer terminated will come into play. This session means we are enabling a connectivity to a PDN, and it is the initial request by having the subscriber ID present in there. Okay, last thing. How these PCC rules would be exchanged between the PCRF and PCEF, how the PCC rules are applied, how they would be transported. They would be transported by using two different mechanisms: push procedure, pull procedure. First, pull procedure. Pull means provisioning of these rules solicited by the PCEF. That means P gateway requested. Solicit means requesting. P gateway requested the rule. That's called as a pull procedure. That means when P gateway detected that there is a new bearer getting established, or a new bearer getting modified, or a existing bearer getting modified, or a existing bearer getting deleted, so you have to request for if, you yourself have to go and talk to the PCRF and request for a PCC rule modification, or PCC rule creation, or PCC rule deactivation, deletion, etc. So that is called as a pull procedure whenever it is requested by P gateway. So that means who is detecting the change, or who is detecting the need for the PCC rule? It is the PCEF or P gateway who is detecting the need for the PCC rule. Then what is the push procedure on the other hand? Push is, on the other hand, is unsolicited provisioning. PCEF is not requesting for it. PCRF is detecting the need for a PCC rule to be activated or modified or deactivated, and he himself pushing the procedure to PCEF. PCRF himself pushing it. Then how can PCRF do it on his own decision making power? How can he do it? If PCRF detected the need of a activation of a new PCC rule from with the information he has received on RX interface from the application server that a new bearer need to be established with this particular quality of service. If application server conveys the details to PCRF, so with the help of that, PCRF will automatically detect that now this user needs a dedicated bearer, even though P gateway doesn't know it, mobile equipment doesn't know it. I know it because application server told me, and now I am going and talking to PC EF and order him to create a new EPS bearer with this new PCC rule that I am providing him. So this is called as a push procedure, which is not solicited by PCEF, unsolicited provisioning. So this happens when information provided to the PCRF via RX information reference point from the application server. So totally there are three components that can detect the need of a IPCAN bearer establishment. Three components can detect that when we require a bearer. Those three components in your entire network are mobile equipment and application server and your P gateway can detect it as well. Now, if UE detects the need of the IPCAN bearer because suddenly one of his applications generating huge amount of uplink traffic, it will have to report it to MME. MME will report it to P gateway that a new bearer need to be established. Then P gateway will request the rules from PCRF, that is pull procedure. Even when application server started sending huge amount of downlink traffic, if P gateway detected that this much amount of traffic cannot be sent on existing bearers, P gateway decides to establish a new bearer. So P gateway detected the need of new bearer need to be established. Again, P gateway will send pull procedure. It will request for the PCC rules, get the PCC rules. After getting the PCC rules, it will start creating the dedicated bearer by communicating with all the components from P gateway to S gateway to MME, MME to E node B to UE, and all the links we will create the corresponding EPS bearer. Sub bearers, radio bearer, S1 bearer, S5, S8 bearer, etc., and activate it. So this is when P gateway getting to know the situation either from the UE or application server. From the UE is reporting it to P gateway, and application server, when he started suddenly sending huge amount of traffic, P gateway detecting the need. This is when P gateway is realizing it. But instead, if your application server himself decided to communicate to your PCRF on RX interface, report him that, hey, this user is now about to, initialize a new solution, initialize a new service. For that, a new dedicated bearer is required. If application server informs this to PCRF, so PCRF will himself will come and explain to P gateway that, hey man, you don't know. I got to know from the application server that there is a need for activating a new EPS bearer with this particular new PCC rule. I'm providing the new PCC rule to you, and you take it and accept it and continue to create that required new EPS bearer. And once that new EPS bearer got established, so you can build the data according to this PCC rule I have provided. So PCRF tells us. So it is either a pull procedure or push procedure. One of the two will be activated. Okay. So how many commands we have on GX interface? Only two commands we have on GX interface. CC request, CC answer. Reauthentication request, reauthentication answer. CC request is PCC rule request basically. CC answer is answer. The CC request and CC answer request is initiated by PCEF, P gateway, to PCRF, and answer is sent by PCRF. This is part of pull procedure. So P gateway is going and communicating with PCRF and pulling the required PCC rule. Whereas reauthentication request and reauthentication answer is triggered by PCEF as part of your unsolicited PCC rule initialization when PCEF received the information from application server, detected the need of activating a new EPS bearer. So it sends this re-authentication request. It is unsolicited. And once that whatever that is enabled by PCRF is successfully accepted by the PCEF, it sends out an answer, re-authentication answer. Okay, so only two sets of messages, that's all. One is part of push procedure, one is pull procedure. That's it. So first we study the pull procedure, the one that is requested by, P gateway, PCEF to PCRF. Lot of information will be there in this. We can identify some of these AVPs, not all, but some of the AVPs. I will send you the specification if you want to study the remaining things. Origin host, origin REM, destination REM. These will be representing your P gateway. And this destination REM is the network ID of PCRF. And CC request type, it is, we already knew CC request type is going to be initial request or update request. One of the two things it will be set to. Request number, CC request number. Then one ID will be identified. Host may be present or may not be present. Origin state ID is your reset number. How many times your node is reset. Subscriber ID is your mobile subscriber's IMSI number or his subscription details. And what are the supported features on GX interface. And packet filter information. This packet filter information is typically your filtering criteria or TFT, how to separate this particular bearer's data by using what TFT rules. What is the bearer identifier? What is the bearer operation? Is the bearer getting modified or is it getting activated or is it getting deleted, etc. What is the IP addresses for the mobile that are allocated? IPv4 address, IPv6 address. What is the IP CAN type? Whether it is IPv4 CAN or IPv6 CAN. Radio access technology type, whether mobile is connected to UTRAN network or JARA network, etc. If it is, if the rule is to be terminated, for example, then what is the cause for the termination? If you are requesting for the termination of that, user equipment information represents your IMEI number, which user, and the quality of service information. What is the QCI, etc., etc. QCI, ERP, and what are your data rates, and all those things will be present inside this. Now, if this bearer is a default bearer, then this will be present. A default EPS bearer QoS would be present. Otherwise, if it is for a dedicated bearer, this AVP would be not present. QoS negotiation, QoS upgrade are also linked to the QoS information. Negotiating the QoS to the next level, upgrading the QoS. So both are similar, basically. So there are some more IP addresses and all these informations and PDN connection ID, which PDN the mobile equipment is connected to, whether the billing should be done in an offline billing mechanism or online billing mechanism, and what kind of event trigger that is taking place, etc. So these kind of information we would be sending. What is the charging rule that is applicable for this as well? The charging rule, and so on and so forth. So if these many details are provided, yes, we need to validate. So even though there are two messages that we have on GX interface, there will be a lot of testers working on GX interface because there will be hundreds of permutations and combinations for these messages. Every combination you have to test. I will be explaining that mechanism when I'm explaining you the testing, but yes. CC answer. CC answer is coming back from your PCRF. and it is going to explain you details about what happened, the result. An origin host origin rem represents your PC RF, and then you have CC request type and number, same as it is, event trigger, and charging rule to be removed or installed, or what is the charging rule, and whether it is offline or online, which one it is accepted for. Um, Again, after how much time PCRF have to talk to PCEF to revalidate it, uh, what is the bearer usage, and if it is a default EPS bearer, it is accepted as a default EPS bearer, and what is the charging information that is applicable, uh, etc., etc., and quality of service information that is applicable. So these are the two primary things. A lot of the internal details will be there in this charging information as well as QoS information. Uh, and these rule details will arrive from PCRF to PCEF. So this is pull procedure. So what is going to be there for us in push procedure? Reauthentication request and reauthentication answer. This information is pushed. The PCC rules are pushed by your PCRF on his own when he detected that there is a need for creating a bearer, or there is a need for modifying a bearer, there is a need for deleting a bearer. He himself will push it or a request. Okay, so um, origin host, origin rem, destination host, destination rem. What is the reauthentication request type? It is initial or update. Again, origin state ID. How many times this is restarted so far? What event has caused this trigger? You can explain that this is due to RX interface related event. You can explain. So what is happening as part of this reauthentication is a charging rule is getting installed or a charging rule is getting removed. And if it is a default bearer, the default bearer quality of service details will be explained. Otherwise, this quality of service it will be explained. If it is a dedicated bearer, it will be a separate package. And revalidation time, after how much time again PCRF will have to revalidate by communicating with the PC. PCEF have to communicate with the PCRF and get it revalidated. Every now and then you have to get it revalidated. So you're going to get an answer accepting it. At the time of answer, it will tell mobile is connected to what kind of IP CAN, what radio technology mobile is connected to, and IP address related details, user present location information, etc., etc. Charging component addresses. If there are any errors, errors will be reported. If the mobile is present under SGSM, SGSM related location information will be provided. Otherwise, LTE related information won't be provided. Result code will explain that it is success or failed. If it is result code is set to diameter failure, failed AVP will be present. Otherwise, these errors won't be present. Errors or failure related things won't be present. All right. So what next we have to study? We are looking into an end-to-end LTE concept now. At the time when the mobile equipment is attaching for the first time to the network. So how many components I'm considering here? UE, eNode B, MME, HSS, S gateway, P gateway, PCRF, and AR. So what kind of signaling messages will be established at the time when the mobile equipment is attaching with the LTE network for the first time? Mobile equipment switched on, detected the need for doing a registration with MME, and it decided to communicate with MME with a NAS message. So UE I've sent a message to eNodeB called RRC connection request to requesting for the radio connection. So before you speak to MME, you must establish RRC connection. And eNodeB sent RRC connection setup to UE, accepted the RRC connection. Of course, before this, we have random access procedure, synchronization, random access procedure, etc. I have ignored those lower level procedures. I'm only considering application level procedures. RRC connection setup. UE sends back RRC connection setup complete by doing the exact configuration that is prepared to him by eNodeB. In this RRC connection setup complete RRC message, UE will also include a NAS message. The NAS message is, it contains EMM NAS message, attach request, EPS mobility management NAS message, attach request, plus will also contain ESM NAS message, PDN connectivity request. So mobile equipment is requesting two things on the NAS. I want to attach myself, and at the time of attaching, at least I must be connected to one PDN. So I'm also requesting you, the MME, to help me to connect to at least one PDN as part of this attach procedure. The rule in LTE is every time you attach, you must be connected to at least one PDN. So we are sending a combined message, EMM as well as ESM, both. You are requesting for attach, at the same time you are requesting for a PDN connectivity request. Great. So what does eNodeB do? eNodeB understands that mobile successfully connected to him on the radio link, and eNodeB extracts this NAS message and decides to send this NAS message to MME on S1AP interface. So by using S1AP protocol, message called initial UE message, eNodeB starts sending this NAS message inside. The NAS message is nothing but this attach request and PDN connectivity request, whatever that is received from the UE. By packing that NAS message into a S1AP message called as initial UE message, we send it to the MME. Okay, so what does MME do here? MME understands new mobile equipment is trying to attach with me. I need to validate whether that mobile user is genuine or not. So MME starts communicating with the HSS by using a procedure which we have studied yesterday called authentication information request on S6A interface, asking HSS, hey, please provide this guy's authentication details, authentication keys, and the random number authentication token, XRES, etc., etc. Please send me all those authentication information so that I can validate this user and see whether the user is a genuine guy or not. I can verify that myself. Please provide me these details. So HSS is coming back to MME and telling him authentication information answer. It is telling him. Meaning, it is telling MME that the MME, these are the authentication details. Take it and validate the user, and you will find the keys also inside it, KASME. With that, you can calculate NAS keys, eNodeB, etc. You can do all that. So that information will be there in this authentication information answer. MME happily accepts this information, and he now wanted to challenge the UE by using a NAS message called as authentication request. So it packs authentication challenge request, a NAS message, inside a S1AP message called as a downlink NAS transport, and send it to eNodeB, indirectly explaining eNodeB that, hey, inside this there is nothing other than a NAS message. Inside this S1AP message, I'm not conveying anything to you. I'm only sending NAS message. Please extract the NAS message, pack it into RRC, and send it to the UE. So eNodeB unpacks this NAS message, authentication request NAS message, and it sends this authentication request NAS message by packing it into RRC message called as downlink information transfer RRC message. We pack this NAS and send it to the UE, downlink information transfer. In S1 AP, we call it as downlink NAS transport. In RRC, we would be calling it as downlink information transfer for forwarding the NAS messages. Okay. So purpose of S1 AP, purpose of RRC is to only pack and send NAS messages. That's it. Because NAS cannot directly travel from MME to UE. So mobile got the challenge. Mobile understood that MME is not accepting my attach silently. He is challenging me. I have to prove my genuinity. So UE calculates something called as XRES, and whatever the XRES he has calculated, it packs that and sends to MME in the form of a NAS message authentication response, which is packed into RRC message called uplink information transfer. Once this RRC message uplink information transfer arrives at eNode B, eNode B is going to unpack that and understand that, okay, so this is a RRC message containing a NAS. I don't have any business to see what is that NAS message. I will have to simply unpack that NAS message and pack it into S1 AP and send it to the MME. So it unpacks it and send it to MME on S1 AP protocol, uplink NAS transport. So this is downlink NAS transport, downlink information transfer, uplink information transfer, and uplink NAS transport. So authentication response. What does MME do? MME has received one XRES from the mobile equipment. He will validate this XRES is equal to the XRES that is received from the HSS. If both these things are equal or not equal. If both these things are equal, MME will find out that the mobile is a genuine guy and can accept his further procedures. MME would decide that I can accept the mobile's further actions. Okay, so what does MME do after accepting this authentication? He decides to ask the mobile equipment to activate the security mode, NAS level security mechanism. So it sends another S1 AP message called as downlink NAS transport containing a NAS message security mode command. Again, the security mode command is not to eNode B. It is for the purpose of sending it to the mobile. So we send it from eNode B to UE, a message called as a downlink information transfer. We send it. And in that we pack this security mode command. Once the security mode command comes to the UE realizes that you need to calculate the needed keys, and he needs to generate all the keys and NAS keys, NAS encryption key, NAS integrity key. You need to generate and accept this security activation for the NAS messages. From now onwards, NAS messages will be encrypted by the NAS protocol himself. But mobile first need to accept it by sending an approval. So it will be sending a uplink information transfer by packing a NAS message called security mode complete, and that security mode complete will be packed into S1 AP uplink NAS transport and we forward it to MME. Now MME understood that mobile has accepted to activate the security mode. From now onwards, NAS messages can be encrypted and integrity protected between mobile equipment and MME. We can exchange the information in a secret way. Nobody in the middle, even if they capture the NAS messages, they cannot understand the contents. They are already getting integrity validated. So nobody can fool you by generating the messages in the middle, because you are validating whether the message is actually originated at the source or not by using integrity protection mechanism. But I'm telling you, this is not PDCP level security, guys. This is NAS level security that is getting activated. MME sends another downlink NAS transport asking the mobile equipment his identity request, nothing but asking for his IMEI number. It sends to the UE NAS identity request requesting IMEI number. So what happens? Mobile, as usually, forwards the IMEI number that is requested in the form of uplink information transfer and uplink NAS transport. We send identity response, IMEI. Once MME gets IMEI, he says that IMSI have already validated mobile equipment IMSI number is proved to be genuine because this authentication response is correct. But now mobile is sending me his IMEI number. I need to validate this IMEI number. And MME sends a S13 ME identity check request to AR to find out whether the mobile is in whitelist, graylist, or blacklist, a diameter S13 message. And AR comes back with ME identity check answer, explaining MME that yes, this guy is indeed a genuine guy is in whitelist. You can proceed further with this mobile's related operation. ME identity check answer. Once that is done, MME decides that all the common procedures that need to be activated for the mobile are completed. This authentication request, security mode command, IMEI validation, all these things are called as EMM common procedures. So all the EMM common procedures are completed. So MME decides that it is the time to accept the mobile equipment's attach procedure. We must accept it. So to accept it, what MME is supposed to do? MME first need to know mobile equipment subscriber details from HSS. Earlier, we got only authentication information, not the subscriber information. So it is the time for us to get the subscriber information as well, along with the authentication information. So MME sends a message to HSS, update location request. It sends to HSS. Asking HSS for subscriber information, subscriber details, and HSS would be sending the information, update location answer, and in this subscriber data would be sent. So MME requires this subscriber data in order to accept, in order to attach the user. Subscriber details are important. Like mobile is allowed to be connected to how many PDMs. For each PDM, what is the quality of service that is applicable for the mobile, etc., etc. All that information would be packed and sent from HSS to MME. Once this is completed, further steps. MME triggers a message towards S gateway, create session request, asking S gateway that, hey man, there is a new user coming up. For this new user, it is the time for us to create the GTPC tunnels and GTPU tunnels for default bearer. So we need to create those tunnel IDs both for control plane as well as user plane. MME triggers it towards S gateway. S gateway forwards this create session request message towards P gateway, tells the same thing to him. For a new user, we need to create EPS bearers. We default EPS bearer, which is the user plane part, and we need to create control plane tunnels also. And P gateway, before accepting this create session response, P gateway wanted to get approval from the PCRF. So P gateway sends a message called a CC request. It is a pull procedure which we have studied today as asking PCRF, hey, I'm activating a default EPS bearer. So it is the time for you to accept it and send me the charging and quality of service rules that you are approving. Please send me those details. I need those, please. So once requested, PCRF is going to come back with the CC answer. Hey, this is the PCC rule I'm activating, and this is the quality of service information I'm approving. This is the charging rule you have to apply. And the traffic flow template parameters are these. I understood that this user ID is so and so. Thank you very much. It sends the answer. So all that rule related offline billing or online billing, everything will be there inside it. Okay. So once P gateway gets that, P gateway got the approval for activating the bearer with these PCC rules. It accepts this create session request by reporting back with create session response to S gateway. Yes, Gateway is has received this create session response and including the pgateways tunnel details. So yes, Gateway also create the needed tunnels, control plane tunnels, user plane tunnels, etc. It comes back to MME with create session response, telling MME that I have created the ones that you have requested. Thank you very much. Don't imagine that these are going through HSS. No, just because in the PPT the things are shown like that. Don't you worry about that aspect. All right. So what next? Once all the control plane and user plane tunnels are created on the network side, on P gateway, on S gateway, and MME also created the control plane tunnels, etc. MME triggers a message towards eNode B called as initial UE context setup request, a S1AP message it triggers. Asking eNode B, it is the time for you to create the UE context for the first time in the S1AP. So in this S1AP message, a lot of details will be included. MME will include the most important thing called as K eNode B, the key that is required for eNode B for PDCP level security mechanisms. And MME also including a NAS message, EMM attach accept, and it is also including a ESM message, default EPS bearer activation request, asking the mobile equipment for the permission to activate the default bearer. And also MME is conveying to the UE that I'm accepting your attach procedure that you have requested. So for the EMM message, there is EMM reply. For the ESM message, there is a ESM reply, default EPS bearer context activation request. But because MME is sending in the initial UE context, MME is asking eNode B to create a EPS, sorry, ERAB. It'll ask eNode B to create a ERAB. ERAB is nothing but radio bearer plus, S1 bearer. We ask the eNode B to do that. But to create any additional radio bearers from eNode B to UE, one condition in LTE is that that bearer must be that bearer must be activated or created only after PDCP level security is enabled. There is one such condition present. So in order to fulfill that condition, what does eNode B do is he keeps the NAS message with to himself. First, it triggers a RRC procedure called as security mode command to activate PDCP level security mechanism by asking mobile equipment's RRC to activate the PDCP level security by giving the ciphering algorithm and integrity algorithm details. Of course, key will never queue. UE can calculate the keys on his own. eNode B calculated the keys from the K eNode B that he has received from this S1AP procedure, initial UE context setup request procedure. Whatever the K eNode B received from that, eNode B calculated the keys. Without sending the keys, we are only sending the command to UE, security mode command, asking the UE for activating this security mode. And UE have to respond back positively. It responds back security mode complete, activating PDCP level security. So once this PDCP level security is activated successfully, now eNode B has got the permission to create the required ERAP parts because ERAP is asked to be created by the eNode B. Your S gateway already created the needed S1 tunnel, S5, S8 tunnel between S gateway to P gateway also has been established. Only the tunnels that need to be created by is eNode B and towards eNode B to UE. eNode B to UE radio bearer, eNode B to S gateway, it is S1 tunnel we need to activate. So what does eNode B do? sends a message to UE RRC connection reconfiguration request, asking UE that, hey man, I'm creating you an DRP right now, data radio bearer. So so it is going to send radio related configuration related to the DRB, what is the PDCP properties, RLC configuration. RLC should be working in UM mode, AM mode, etc., etc. MAC configuration, logical channel configuration, physical channel configuration, all those things will be there in RRC connection reconfiguration request. But along with this, whatever the NAS message that is received from MME to Inode B, which was stopped earlier until the security mode is activated, now the NAS message gets forwarded along with this RRC connection reconfiguration request. The EMM attach accept that is coming from the MME and ESM default EPS bearer activation request. This NAS message is packed into RRC connection reconfiguration request and sent to UE. Now, what does UE do? UE first comes back with RRC connection reconfiguration complete, explaining Inode B that, yes, man, thank you very much. I have successfully created the required radio bearer. Thank you. It is coming back and explaining it to Inode B. Now, once the radio bearer is got successfully created, Inode B sends a message to MME called S1AP initial UE context setup response. Because initial UE context setup request is sent, for that Inode B is responding back to MME initial UE context setup response. It is responding back there. And in this, Inode B will include his tunnel details, his GTPU tunnel details for S1U interface. It will include the tunnel details and respond back to MME and tell the MME that, hey man, I have successfully created the ERAP that you have asked for. The ERAP radio bearer I have created successfully, and S1 tunnel also I have created. These are the tunnel IDs. I am sending it to you. Once done, what does MME do? MME wait for mobile equipment's further message. Meanwhile, mobile prepares an uplink information transfer NAS message, RRC message. Inside that RRC, it will include a NAS message containing EMM attach complete. So attach procedure completion is being reported by the UE, and a ESM message default bearer activation acceptance. So mobile is accepting the activation of the default bearer that is already created successfully. How do we know that it is created? With this RRC connection reconfiguration complete, mobile is reporting that radio bearer is successfully created. And with this, we are reporting that S1 bearer is also successfully created between eNode B to S gateway as well. This is already created, but MME needed permission to activate this default EPS bearer because he has requested one such thing earlier, default EPS bearer activation request. Now we are sending default bearer activation acceptance. NAS message. Oh, because this is just a NAS message, RRC message carrying NAS. eNode B extracts that NAS message and sends that NAS message to MME. MME understands that, okay, mobile has completed my attach procedure by sending attach complete, and mobile also accepted the activation of default EPS bearer that I have requested him to accept. So once the acceptance is completed, once the default bearer activation acceptance is done, so what MME is going to do? MME would send out a message to S gateway called modify bearer request, explaining S gateway the tunnel details that are created by eNode B. So whatever the tunnel details that are reported, S1U tunnel details that are reported by eNode B, those tunnel details are being now forwarded to S gateway in a message called as modify bearer request, letting the S gateway know, hey man, you have already successfully completed S5, S8 and the S1. Now I have already made eNode B do the same. These are the eNode B tunnel details. I'm sending it to you. If you want to send any downlink traffic to the mobile, you need to send the downlink traffic to these particular tunnel IDs. that are created by node B. We are reporting it to S gateway. Now S gateway have to accept it. It will come back with modify bearer response. It comes back with GTPC modify bearer response, accepting that um, tunnel details. So once the tunnel details are successfully accepted by S gateway, we can say that the default EPS bearer is activated, because radio bearer is existing right now. Now S1 enode B tunnel details are known to S gateway. S gateway tunnel details are already known to enode B in this message that are sent. S gateway tunnel details are sent to enode B in this message. So both are known. S gateway, P gateway knew the tunnel details from one another. So S gateway tunnel details are sent into P gateway in this message. P gateway tunnel details are sent to S gateway in this message. So they know the S5 safe tunnel details as well. So all the three links are existing. Radio bearer, S1 bearer, and S5 safe bearer. We can say that the default bearer is in activated state right now continuously. So if the default bearer is activated, we can also conclude that mobile equipment is successfully connected to a PDN. That means mobile has activated a service successfully connected to a PDN network, packet data network. So every time mobile gets a service activated, MME triggers a message to HSS with a procedure called as notify request, notifying to the HSS that, hey man, I'm letting you know that mobile has just now activated a service connected to a PDN, connected to a packet data network. I'm notifying this to you. Thank you very much. You only have provided the subscriber information, I know, but it's my duty to report you that whenever mobile connects to a service or disconnects from a service, so as per my duty, I'm reporting it to you. Notify request. And as usual, for every Daimeter request message, there is an answer. HSS comes back with notify answer. So with that, we can consider the mobile equipment is in attached state with the LTE network attached. So this is the overall procedure that takes place. But we have to study a lot more with actual logs. So when we come back tomorrow, we will be doing end-to-end log analysis. Here we have only seen high-level messages, but what those messages contain at low level, what information would be present inside. We do that log analysis.